Okay, so today, today we're going to do applications. God bless you. Today we're going to do applications. Now, the parameter gives you the third variable. So now when we shoot this arrow, before you could only judge time, God bless you, and vertical distance. Now we can judge three things: vertical distance, horizontal distance, and time as we go through it. So let's just take a look and see, what does this mean to us. An arrow is shot into the air with an initial velocity of 200 feet per second at an angle of elevation of 48 degrees. We want to find out when and where will it strike the ground. Now, you pull the arrow back. Here's your angle of elevation. You kind of have to assume he's laying on the ground. We didn't give it a plus thing. So he's laying on the ground. He pulls the arrow back, and when he lets it goes 205 feet per second. That's the velocity. Anything that deals with the x is horizontal. Any horizontal change will affect the x value. In other words, if I moved 4 feet forward and I wanted to cheat and I moved 4 feet forward, that's going to affect my horizontal. I'll add 4 feet to my x. If I stood on a platform and I was 5 feet up, that's going to affect vertical. That's going to affect my y. Generally, what has a big effect in here is wind speed. Right now, this problem won't have any wind speed in it. Wind speed is like if you've ever thrown a ball in the air and the wind is behind your back, the ball goes further. If the wind is right at you and you're throwing that, yeah, it kind of looks like it kind of hangs up there. Or a frisbee. Yeah, kind of just stays around there. Good, like a boomerang. Okay, now, so any horizontal change or horizontal factors will go to your x. Any vertical factors will go to your y. And again, you remember in parametrics, you have a pair all the time. Now, parametrics, pretty cool. Now, your angle is in degrees, so your mode has to say degrees as well. So let's see if we can set these two equations up. So for x1, we start with your velocity. They both start with velocity, 205. Now, here's your parameter, t. T is your time. That's your third parameter. That's what we're going to chart as it's moving, is the time. Then we take the cosine of your angle, 48 degrees. And right now we have no wind speed, so we have no effect horizontally on us. Your y component says velocity, t, the sine of 48, and then look what it does. That looks like a little familiar when you make a parabola and you do this, minus like 2x or whatever you write on this thing. This is your pull of gravity. This is what actually forces your arrow to come back down. Otherwise, your arrow with no gravity would keep traveling and traveling. And, yeah, well, you guys that take physics probably see this as 32 over something. I forget what the, well, obviously it's over 2, but it's 32 over some other factor goes in there. So we have to have this part here. This is our pull down. This is our gravitational pull. This forces my arrow back to the ground. Now, we're going to take this and we're going to put this in your parametrics. Okay, but before we do this, let's see if we can think of a window. We've got our time, our min and max. We have our x, our min and max. We have our y, our min and max. How much time do you think it will take to hit the ground? So what should we put in for time?
Like 10 seconds.
Okay, from 0 to 10. Now it's going to ask you for a scale. Since it's a small range, just put the scale of 1. Good. Good. You guys are quick. What would your x min and your y min be?
The distance.
So what should I put them as?
0 to something.
0 to something, good. Because we never have a negative distance, right? Never. So, I don't know, what would you say? What kind of horizontal distance do you think?
100.
100 feet? Okay, let's go 100 both ways. And then once we get it into your graph, we can take a look at your table and see where it actually is. But at least this gives us a good start to put it in there. So we're going to go in, and we're going to come to this guy, and we're going to put in your pieces. And then we're going to go to your window and put your values in. Okay, get your y equals. Get your window set up. Make sure your mode is degrees. Calc. You're going to need to know how to do this.
What?
It never hit the floor.
So does the X max have to be bigger?
Ah, so it never did hit the floor. So let's go to your table and see why. So, start, if you use somebody's calculator, start it at 0 and increment it by 1 right now. Change your table set. They were working in thousandths of a second, so change your table set. Just go from 0 to 1.
Wait, how do you get
Second window. Set your table back to 0 to 1. Now, look at your table. What part is going to tell me when I hit the ground? T, the X, or the Y?
all of it is on the 0, right? Or
No. Which one should be 0 when I hit the ground?
Why?
The Y. Good. The vertical. When it comes down and hits the bottom down here, the ground,
oh, yeah,
is it Y equal to 0? Right?
Yeah.
So, scan down your Y's until you see it equals 0. Or get close to 0. Notice between 9 and 10, that's when it hits 0 somewhere, right? And it is very close to what Randolph said. We said 10 seconds. So you're 9, something over 9 seconds.
8.
Now, X is my horizontal distance. So somewhere above this number. So make it 1500 to the max. X is horizontal. That keeps increasing. My Y is the guy that makes the parabola. So it's going to reach a maximum, turn, and come down. So kind of guess around the maximum somewhere. See the turning point right in here between 361? See the turning point? I'll say 400. Remember, this is just your window. So for X max, we're going to go, what did we say, 1500? That's the horizontal distance. And for the Y max, we'll go 400. All you want to do is be able to catch this whole parabola because we're going to have to trace this. So, see it? Now, say, I just want to show you something. Say I wasn't thinking and I said an arrow, it's going to go faster than 10 seconds. So what happens if I only went to 5 seconds? Watch what happens to my arrow.
It's not as smooth.
Well, but not my step, but my time. So if I only went 5 seconds, when I stop at 5 seconds, my arrow's still mid-air.
Whoa.
And that's when your graph stops. When your graph stops, your time isn't big enough. Sometimes you forget your T's. Your mode has to be degrees. Because you're in radians, it makes it go crazy. You're saying 48 radians, which is large. Okay, so let me set my time back to 10. You know, just like different parts that might throw you off a little bit. Okay, so now, according to your problem, you need to know when and where will it hit the ground. Well, here it hits the ground right here. The when is my time. The where is my distance. So this guy a horizontal distance. This one is a vertical distance, and here's my time.
So where is it the when is time and the where is distance?
The when is time, like when will you be home, the time. You know, how far, where did you land, how far away, where did you land from here. Okay, so my time, here's my third parameter, my time.
You have to make it squiggly like that?
No, I'm just showing you the difference, that's your time.
Oh, okay.
Your time is actually tracked along your parabola. So, no, you just can make your straight one. Now, watch how we look at your time. Hit the trace button, right up here. Hit the trace. Look how this gives this to you. Here's your three parameters. Time, X, and Y. So as soon as I arrow, now don't forget, our table said, our scale said by ones. So here I am, 1 second later. I am 136 feet in the air and 137 feet horizontally away.
So it's gonna give me the full time second, but not the other.
Right, then we're going to have to break it down. Remember, unfortunately, we always go 3 decimal points, 3 decimal places, which is why we have to get. That is pretty hard for an arrow, right? To go 1,500 feet in the air.
That's crazy.
They must have had one of those big, powerful arrow things, right? Those ones that have all the tension rods in it. Now watch, guys. Keep going with this. Keep hitting your advance arrow. I'm advancing. Watch what happens. It's the Y that I want to come to 0. Okay? I want you to look up here. The Y has to come to 0. Okay? Up. It just went after the 0. It just went underground now.
But that's what we had on the
So, yes, that is exactly what was on your table because we only said advance by 1. So now we're looking exactly at your table. Now I want you to estimate this. Make sense out of this. If at 9 seconds I'm 75 feet above the ground and 10 seconds I'm approximately 75 feet below the ground,
Really 9.5.
it's really close to 9.5, right? Now, if I did second calc and put a value in for 9.5, look what I would get. I'm so close to the ground. I'm 3 feet away from the ground. Now, in precalc, we go 3 decimals. Because we're that close, I don't want to have to keep testing 9.510, 9.520. Instead, now I'll go to my table and I'll set my table up so that I can look between the 9 and the 10. So I go to table set, I say start at 9.5 and increment by 0.001. I need 3 decimal places worth when I do this, right? So you don't have to regraph. You just have to go second table and look where I am. Now I'm looking for my Y to hit the ground. Has my Y hit the ground yet? No. So I just scroll down my table. I'm getting closer. Whoop. Getting closer. There I am. Somewhere right in here, I hit the ground. Now, somewhere between 9.521 seconds and 9.522 seconds. But that's okay. You're close enough with the 9.522 seconds. That's when. That was my time. 9.522 seconds. You remember in precalc, we always go 3 decimal places. That's annoying, yes, but work your table. If you do your T-step on your graph is going to go so terrifically slow, you probably fall asleep before it hits the ground. So once you kind of like bounce around.
When you put the 9.521, because once you get to it already like hit.
Yes, it went below the ground, but as of this point, you didn't hit yet. You're still 0.0, so you really haven't hit the ground. But it's like minuscule. So if you told me 9.521 or 9.522, I have no problems with that. Technically, we can estimate it somewhere in between there, but we only have to go 3 decimal places. Yeah, so you're close enough. So you technically didn't hit the ground yet, but you're very, very close. So now, let's see what your other values give you. This distance is your horizontal distance right here. Your vertical distance is 0. You're on the ground. Here's my time, ladies. Here's my horizontal distance. This is the where part of that equation. So, in order for you to see it better, scroll over it. Come down here and scroll over it. Let me erase this. You could kind of see it before it was rounded. Yeah, they have to round to get that on your table because there's way too many positions. But when you scroll over it, you can see it better. So I would have to say this is 1306.150 feet away from me. I shot the arrow. It took 9.522 seconds to hit the ground, and when it landed, it was 1306.150 feet away from me. Okay? Now, when you're looking for the height, how high? Usually they'll say, like, at what point was it the highest? How long did it take to get the highest? Work your graph a little bit. If it took 9.5 seconds.
So you're between the...
So yeah, isn't this perfectly symmetrical because we did start at the 0?
Yeah.
Wasn't your point 0, 0?
Yeah.
So what's half of 9.5?
4.25.
Ooh, 4.25? No, 4.75.
Yeah, 4.7.
4.75. So watch. Second calc, which you were very, very close. I'm going to do a calc for number 1. Maybe. My thing is frozen here. Okay, here it goes. We say 4.75. Watch where this time is. Real close to the top, right? So now, I'm going to go to my table set. I'm going to start it at 4.75 and increment by 0.001. Because remember, I got to round 3 decimal places. Now, you're looking for your turning point in your y. This gets a little tricky because look what happens. It's all the same because it rounded it. It rounded it. So, I would go, if you want to go, let's see.
Obviously, it's getting closer to the edge.
Yeah, if you go over like this, watch. If you go over here, see this one here, it's 635, 6356, they're all pretty, very, very close to 6350. It's actually decreasing right here. If you pick one of these, I'm fine with it. I'm fine. So say we pick 4.745 seconds. We reach the maximum height of 362 point, let's say, 636. Okay, does everybody see what we're looking at? When it hits the ground, your y is 0. But your x is your horizontal distance, your t is your time. What time did it hit? How long was this arrow in the air? When we're at the maximum height, that's halfway between. So we kind of figured, well, it's got to be like halfway between 0 and 9.522. So we took half of that, and we started there. Now, because these are so close, you don't really get to see the difference until you scroll over. You're looking for the point that it reaches the height and it turns. You're looking for the turning point.
Turn up or turn down?
It's got to turn down, right? It's got to go up, hit the point, turn down. So you're going to be real close right in there, and for us, I'm happy with that. I'm very happy with that. Okay? All right. An NFL punter is at the 15-yard line, and he kicks a football downfield with an initial velocity of 85 feet per second at an angle of elevation of 56 degrees. Draw a complete graph of the problem situation. How far downfield will the football first hit the field? And determine the maximum height that the ball traveled And what is the hang time? Hang time is the total time in the air from the time that he kicked it to the time that it hit the ground. Now, we've got a couple of things going on here. He is 15 feet away. We want to just leave that 15 to the end. Here's your football field. Your football field from end zone to end zone is 100 yards. It's 100 yards. When he kicks it, he's not standing at the goal line, is he? He's standing at the 15-yard line. He's over here when he kicks it. Okay? So he's 15 yards off the end zone there. Right? He's not going to stand in the end zone and kick it. They would not be able to hike it to him. Right? So, yeah, they could, but...
Is the ball on the 15-yard line?
He's-
Because I have to back up.
Yeah, but he's going to kick it from the 15.
Oh.
He actually kicks it from the 15. Okay, so his should go like this and should land somewhere, right? Hopefully farther away. All right, now remember, you have two components to this. An X1, which is horizontal, and a Y1, which is vertical. So let's start with your X1. What's the velocity of this guy?
85 feet.
85 feet. Both of these get 85 feet. Both of them get a time parameter. The X gets the cosine. Good, because cosine always went with the X.
Cosine 56.
Cosine 56. Because he's 56 degrees.
And then
Okay?
the y gets minus 1.
Good. The Y has to make this turn because otherwise, vertically, it would keep going up and up and up and it would never turn. Well, gravity has 32 over, well, in this case, 32 over 2. But the final number, I forget how they find the final number, but for us, it's been coming out negative 16. And I don't know if you remember from algebra 2, negative 16 t-squared, which if you're doing any of those ones where you kick the ball or you shot an arrow, it was always negative 16. You had to use the gravitational pull. Okay, so let's see if we can figure out our window ourselves. T, from 0 to what? How long do you think it's going to take him to kick this ball? Less than 10 seconds. Okay, X min.
I'm going to say
And max.
8.5.
You're going to say 8.5? Okay, so the mins are zeros, right? How far down the field maximum could we go? 50 yards? Well, I can even go to the 100-yard, right? Yeah. So you think he kicks it 50 yards? Is 50 yards a good punt?
That's an average punt.
Okay, so let's go 75 yards.
That's pretty.
That would be a cool punt. On this one, would be a cool punt. Okay, they're heading for a safety on this
Wait,
one.
is that feet or yards?
Yards. Yards. Okay,
That's the end zone.
why? Why is how high this goes? He's got a good angle on this. So how high do you think he could go? 100 feet. We're going to be in yards. Since we did this in yards,
75 yards.
so 75 yards.
No.
That's pretty high in the
All
sky.
right, let's shoot for this.
That's like
So we modify. Okay, so let's put this in and see where we land.
you have a good imagination.
Guys, get it in your calculator.
It's just a straight line. Well, yeah, oh,
Yeah.
here, let's
Oh, look at my little tiny parabola. Yeah, my little tiny parabola works well,
Wait, what's the
but let's narrow this down a little bit. I set it to 1. Oh, I didn't change my window, that's why. I didn't change my window.
Mine doesn't look like
What was your X max? 75? What was your Y max? Oh, you made both 75? Okay.
You're crazy. I'm about to hear.
He is pretty tough. Oh, My goodness.
It's gonna be longer. It's gonna be a longer punt. It's gonna be
You're gonna kick it out of the stadium?
I guess it's gonna kick it pretty far.
good.
Guys, please. Always check to make sure you have your negative 16 squared. And let me see what I did wrong here. Oh, here's the problem. You asked feet and yards. Which is velocity?
Velocities and feet.
Velocity is in feet. And he's kicking yards. So what do we have to convert? Yards to feet. Yards to feet.
75 divided by 3.
No,
What?
times. You get more feet than yards.
You're funny.
So even if it's 80, 80 times 3 is what? 240. So let's make both of these 240. Just estimate it. Ah, so he's kicking it pretty far. He's just not kicking it very high. And that's okay. I don't have to change my graph because I get the path of it, right? The path of it, I understand where it's going. Now, it wants us to determine the maximum height of the ball when it's above the ground, above the field. And we also need to determine how far downfield it will go. So let's do the downfield guy first, and that'll give us our hang time. We want to know how far downfield it's going. Now, it depends how you interpret this. How far down the field, if you want to figure out exactly when it hits the ground, what is the yard line, then what are you going to have to do? Well, you're going to have to convert it back, but you're going to also have to add these 15 yards after you convert it back. In other words, if you want to say what yard line are we at, then you have to convert it back to yards, add your 15. If you want to know how far down the field in the distance that he kicked it, then you just take it without the 15. Probably the second one. But once you convert it back, you can just add the 15. Yeah, I know I'm running out of time. Okay, so listen to me, guys. So